Dear everyone, I will present you the MAST project. MAST stands for Microfluidics for Structure Reactivity Relationships aided by Thermodynamics and Kinetics. One of the goals of its project is to study the influence of a substituent R on the reaction center by considering also the solvent effect. This project was funded by the German agency DFG and by the French agency INR. The consortium of this project is with three universities: INSA Rouen-Normandie for the kinetics part, and the principal investigator is Sébastien Leveneur. The microfluidic part led by University de Rouen and CNRS, where the principal investigator is Julien Legros, and the thermodynamics part led by the Technische Universität Dortmund University, and the principal investigator is Christoph Held. This project has started in February 21 and will be ended in April 24. The main contributor of this project are, of course, the PhD student Cindy Bacco, Alexandre Cordier, and Marcel Klingsig from Dortmund University. In MAST project, we want to study the different platform molecule issue from the lignocellulosic biomass. And we, for example, we will start with the fructose molecule, and by solvolysis in different alcohol, try to get the levulinate here. This levulinate will then be also transformed into gamma-valolactone by hydrogenation. We also study the esterification of levulinic acid over homogeneous catalyst and over immobilized enzyme. The question that we were asking to ourselves is, we can perform, for example, the fructose in different alcohol and then get the corresponding levulinate. What could be the effect? Do we have any relationship between the substituent R and the kinetics? And the same question also was for the hydrogenation and the esterification. Of course, we cannot perform all these experiments in the same solvent all the time for different reasons, so we need also to consider the solvent effect, and for that we need to have some thermodynamic model. So that was our question. What is the effect of the substituent R on the kinetics? And as I told you, we need also to consider the solvent effect because we sometimes cannot perform this experiment in the same solvent. So what is the solvent effect of the kinetics? And what we need to do is to perform some experiment in the absence of temperature or gradient or concentration gradients. So to make this investigation, we have used the three different tools: the linear free energy relationships that will help us to understand what is the correlation between the substituent R and the kinetics, the EPC equation of state to be able to predict the solvent effect on the kinetics by, for example, considering the activity, and then the microfluidic system to be able to perform some experiment in the absence of any gradients. Thank you for your attention, and if you have any question, feel free to contact us.